We spend most of our lives worrying about the wrong kind of apocalypse. We worry about the things that might kill us, like a nuclear war, a pandemic, or an asteroid hitting the Earth. These are terrible events, but they are technically solvable problems. If we are smart enough, we can dodge the asteroid. If we are careful enough, we can avoid the war. We operate under the comfortable assumption that survival is a game of skill. We believe that if we play the game perfectly, if we make no mistakes, we can keep the civilization running forever. But this is a fundamental misunderstanding of the game board we are playing on. The universe is not a static stage that will let us perform as long as we know our lines. The universe is a machine that is in the process of breaking down. We are going to look at the physical evidence that suggests our reality has a hard expiration date. We are not talking about the death of a planet. We are talking about the structural failure of the laws of physics themselves. We are going to examine the theories that show how the very concepts of time, distance, and matter will lose their meaning. The walls of our prison are moving in. The energy that powers our thoughts is running out. And the vacuum of space itself might be waiting for the chance to delete us. The question is not, will we be able to survive the next 100 years? The question is much darker. What do you do when you realize that the house you live in is slowly catching fire, and all the doors are locked from the outside? To understand why the story inevitably ends, we have to ask a simple question. Why does time move forward? Why can you remember the past but not the future? Why does a glass shatter when it hits the floor, but a pile of shards never spontaneously jumps up and reassembles itself into a glass? It feels like a philosophical question, but the answer is purely mechanical. It is driven by the second law of thermodynamics. This law introduces the concept of entropy, which is essentially a measure of how spread out energy is. Think of the universe like a cup of hot coffee sitting in a cold room. The coffee has low entropy because the heat is concentrated in one place. This concentration is useful. It creates a difference, a gradient that allows things to happen. But nature hates gradients. Nature wants equality. So, the heat spontaneously flows from the hot coffee to the cold air. It spreads out. You might ask, but isn't energy conserved? Does the heat disappear? No. The first law of thermodynamics says energy cannot be destroyed. The heat is still in the room. But, and this is the terrifying part, it is now useless. Once the coffee and the room reach the exact same temperature, no more heat can flow. No more work can be done. Nothing can change. This state is called thermodynamic equilibrium. Now, scale this up. A star is just a massive cup of hot coffee in a very cold universe. Every second, the sun blasts out massive amounts of energy. It is furiously increasing the entropy of the solar system. It is burning its fuel to create light and heat. But just like the coffee, that energy is spreading out into the void, never to return. We are living in a temporary phase of imbalance. We are surfing on a wave of energy that was created by the Big Bang, but the wave is crashing. The problem is that the universe appears to be a closed system. There is no outside battery charger. There is no one coming to wind up the clock. This implies that the total amount of useful energy in the cosmos is finite, and it is being consumed every time a planet spins. A chemical reaction occurs, or a neuron fires in your brain. We are burning the furniture to keep the house warm. So what happens when the fuel runs out? What happens when every star burns its last atom of hydrogen and fades into a white dwarf? What happens when the temperature of the entire universe becomes perfectly uniform? This leads us to the first true horror of our timeline, the heat death. It is a moment where the arrow of time snaps because there is physically nowhere left for it to go. So, what does the death of time actually look like physically? We usually picture the apocalypse as a noisy, chaotic event filled with fire and screaming, but that is a mistake caused by our biological need for drama. Fire and noise are signs of life. They are evidence that energy is still flowing and gradients are still clashing. The heat death is the exact opposite. It is not a bang. It is a suffocating absolute silence where the temperature everywhere levels out to just a fraction of a degree above absolute zero. When the universe reaches thermodynamic equilibrium, the concept of history simply evaporates. Time is not a physical object you can hold in your hand like a rock. Time is a measurement of change. You know that 5 minutes have passed because the clock hand moved, because your heart beat 300 times, or because a shadow crept across the floor. But in the heat death, nothing moves. Nothing changes. If you were an immortal observer floating in this void, how would you define a year? You could wait for 1 trillion centuries and the universe would look exactly the same as it did the moment you arrived. There is no biological clock. There is no atomic clock. There is just an endless, frozen now. This renders the very idea of a future obsolete, because if nothing can happen, the future cannot exist. Physics suggests that without events, time transforms from a river into a frozen dimension, a static coordinate like width or height that no one is traveling through. The arrow of time doesn't break. It simply loses its target. The universe becomes a coffin that has been sealed shut, perfect and unchanging. But while time is grinding to a halt, space is doing something much more violent, effectively pulling the rug out from under us before we even have a chance to freeze. For most of the 20th century, we operated on the comforting assumption about the shape of space. We knew the Big Bang threw everything outward like shrapnel from a grenade. But we assumed that gravity, the attractive force between all matter, would eventually act as a brake. We thought the expansion would slow down, that the galaxies would pull on each other, and maybe, just maybe, everything would stop and crunch back together in a cycle of rebirth. It felt like a breathing cycle. Inhale, exhale. But in 1998, 2 teams of astronomers looked at distant Type 1a supernovae to measure cosmic distances and found something that shattered our understanding of physics. The supernovae were dimmer than they should have been, which meant they were farther away than the math predicted. The expansion wasn't slowing down, it was speeding up. Gravity had lost the war. Something else was pushing the universe apart, a mysterious pressure inherent to the vacuum of space itself that we now call dark energy. We don't know what it is, but we know what it does. It creates new space. Every second, everywhere in the universe, new emptiness is being generated between the galaxies, pushing them apart like dots on the surface of a rapidly inflating balloon. Think of it like running on a treadmill that is controlled by a malicious algorithm. You are trying to reach a friend on the other side of the gym, running at a steady speed, but the floor beneath your feet is stretching. The treadmill is speeding up. At first, you can keep up, but dark energy is relentless because it feeds on itself. The more space there is, the more dark energy there is, which pushes the expansion even faster. It is a runaway feedback loop. The floor is moving faster than your legs can carry you. This destroys the dream of intergalactic exploration because the galaxies we see in the Hubble Deep Field are being carried away from us on a tidal wave of expanding space. They are receding faster than we can ever build ships to chase them. But this speed doesn't just trap us, it creates a hard physical limit to what we are allowed to see. This acceleration generates a terrifying boundary known as the cosmic event horizon. We usually associate event horizons with black holes, the point of no return where gravity is so strong that light cannot escape. But the universe has a horizon too, and it works in reverse. It is the distance at which space is expanding away from us faster than the speed of light. Einstein said nothing can travel through space faster than light, but space itself has no speed limit. It can expand at any rate it wants. If a galaxy is far enough away, the space between us and it swells so rapidly that the light it emits can never reach us. It is like a swimmer trying to paddle upstream against a current that is moving faster than he can swim. He will never reach the shore. He is causally disconnected from us forever. Here is the true horror of the horizon. It is not static. Because the expansion is accelerating, the horizon is effectively shrinking in terms of what we can reach. Objects that are visible today will eventually cross the line and vanish from our reality. Look at the night sky and imagine a thick, white fog rolling in from the edges of the universe. You see distant stars and galaxies, but the fog is swallowing them one by one. You shout to them, you try to send a signal, but the fog eats the radio waves. Once a star crosses into the mist, it is gone. It is still there physically, burning and existing, but it has exited our observable reality. We can never see it again. We can never know if a civilization lives there. Cosmologists estimate that every single second, roughly 20,000 stars cross the cosmic horizon and disappear from our future. We are bleeding data. The sky is effectively emptying out. Future civilizations born 100 billion years from now will look up and see nothing but the darkness beyond our own galaxy, trapped in a lie constructed by the horizon. We are the last witnesses to the full scale of the cosmos, but even our local neighborhood isn't safe, because this expansion doesn't stop at the horizon. It eventually comes for the structures closer to home. This acceleration leads to a profound kind of cosmic gaslighting. Imagine a civilization born on a planet in the Milky Way 100 billion years from now. By then, the expansion of space will have pushed all other galaxy clusters beyond the cosmic horizon. The light from the Virgo cluster, the Coma cluster, and the thousands of beautiful spiral galaxies we see in our telescopes today will have stopped arriving. These future astronomers will build powerful instruments. They will scan the deep sky, and they will see absolutely nothing. They will see the stars of their own galaxy, which will likely be a merged ball of old stars. But beyond that, they will face a wall of perfect, eternal blackness. They will construct a model of the universe based on their rigorous observations. They will conclude that the universe is static, finite, and consists of only one single island of stars surrounded by an infinite, empty void. They will have no data suggesting a Big Bang, because the cosmic microwave background radiation will have faded away. They will have no data suggesting expansion, because there will be no distant objects to measure against. They will build a physics that is internally consistent, logically sound, and completely wrong. How could they possibly know the truth? How could they know that they are living in a tiny fragment of a much larger reality? They cannot. They will be trapped in a lie constructed by the horizon itself. We are living in a privileged moment. We exist in the only time window in the history of the universe where the cosmos is transparent enough to be understood. We can still see the echoes of the beginning and the signs of the end. But this window is closing fast. We are the witnesses. And when we are gone, the truth about the scale of the universe will disappear with us. But knowing the truth does not save us from the cage. It just allows us to see the bars. And if you look closely at the behavior of gravity, you will realize those bars are much closer than the horizon. So, what is left for us in this dissolving world? If the rest of the universe is running away, what can we keep? The only force strong enough to fight the push of dark energy is gravity. But gravity is surprisingly weak over long distances. It can only hold together our immediate neighborhood, a structure known as the local group. This cluster contains the Milky Way, the Andromeda Galaxy, and about 50 smaller dwarf galaxies. That is it. That is our entire future allotment of matter. Everything else, the billions of other galaxies, the superclusters, the vast filaments of the cosmic web, is already uncoupled from our gravity. They are drifting into the dark. In about 4 billion years, the Milky Way and Andromeda will collide and merge into a single massive elliptical galaxy, often nicknamed Milkdromeda. This new supergalaxy will be our final fortress. For a while, it will be a bright and chaotic place, full of new star formation. But eventually, the party will end. The view from a planet inside Milkdromeda will be terrifyingly lonely. The night sky will still have stars, but if you look past them, there will be no background glow, no distant nebulas, no other galaxies, just a hard stop. We will be trapped on a solitary raft in an ocean that has become too wide to cross. But even this raft might not be safe. The standard model of cosmology assumes that dark energy is a constant force, a cosmological constant. We assume it pushes with the same strength forever. But what if we are wrong? What if the pressure of the vacuum isn't stable? What if the vacuum gets angry? This leads us to a theoretical possibility that turns the lonely isolation of the future into a violent, shredding nightmare known as the Big Rip. To understand how the universe could physically tear itself apart, we have to look at a variable called W. In the equations of general relativity, this letter represents the equation of state for dark energy. If W equals -1, then dark energy is constant. It pushes the galaxies away, but it leaves the galaxies themselves alone. Solar systems and atoms remain safe because their local gravity is stronger than the gentle push of the vacuum. This is the standard lonely scenario we just discussed. But in 2003, the physicist Robert Caldwell from Dartmouth College proposed a terrifying alternative. What if W is less than -1? This hypothetical substance is called phantom energy. Unlike normal dark energy, which stays constant as the universe expands, phantom energy gets denser. The more the universe stretches, the more powerful the phantom energy becomes. Think of it like an interest rate on a debt that grows faster than you can pay it off. At first, the expansion is slow. It only pushes apart the distant galaxy clusters. But as the phantom density rises, the repulsive force becomes stronger than gravity on smaller and smaller scales. It starts to overcome the forces that hold the local group together. Then it overcomes the gravity holding the galaxy together. Then the solar system. Then the planet. Finally, it overcomes the electromagnetic, nuclear forces holding your atoms together. The vacuum itself transforms into a shredding machine. It is not just empty space anymore. It is an active agent that wants to pull every single point in the universe away from every other point. If Caldwell is right, we are not heading for a long, cold sleep. We are heading for a violent execution, and we can calculate exactly when it happens. If phantom energy is real, the end of the universe is not 1 trillion years away. It could happen much sooner, and the countdown follows a precise, accelerating rhythm. Let us walk through the final timeline calculated by the models. The process begins quietly. For billions of years, we just see the other galaxies disappear faster than expected. But about 60 million years before the end of time, the phantom energy becomes strong enough to overwhelm the gravity of the Milky Way. Usually a galaxy is a bound system. The stars orbit the center because the collective gravity holds them in place. But suddenly, the anti-gravity of the vacuum becomes stronger than the glue. The Milky Way begins to unzip. The stars at the edges fly off into the void first, followed by the inner spiral arms. The structure disintegrates. We would look up at the night sky and see the band of the Milky Way, that white river of stars, begin to widen and dissolve. The stars are being peeled away from us. We are now drifting alone with our sun in a rapidly darkening void. But the horror is closing in. 3 months before the end, the density of phantom energy becomes so high that it overpowers the gravity of the solar system. The planets are ripped from their orbits. Jupiter, Saturn, and Mars drift away into the blackness. They are not destroyed yet. They are just untethered. Earth is now wandering alone in the dark, separated from the sun. The temperature begins to drop instantly. But freezing is the least of our problems, because the space itself is now expanding so fast that it is tearing at the fabric of the planet. The final minutes of the Big Rip are a descent into madness. 30 minutes before the end, the repulsive force of the vacuum becomes stronger than the gravity holding the Earth together. The planet does not break into chunks, it explodes from within. The core expands. The crust cracks open. Every mountain, every ocean, and every building is pulled apart by the expanding space between its molecules. But the phantom energy is not done. It is hungry for smaller structures. In the last fraction of a second, 10 to the power of minus 19 seconds before the end, the force overcomes electromagnetism. This is the force that holds electrons to atomic nuclei. It is the force that allows chemistry to exist. Instantly, every atom in the universe is ripped apart. Electrons are stripped from their orbits. Then, at the very final instant, the force overcomes the strong nuclear interaction. Protons and neutrons are torn into quarks. The fundamental particles of matter are isolated, unable to interact, unable to touch, expanding away from each other faster than the speed of light. The universe is now filled with lonely particles that can never communicate with one another again. Reality has been shredded down to its pixels. This is the Big Rip. It is the most violent death imaginable for the cosmos. But you might say, this is just a theory. The data suggests dark energy is constant. We are safe from the shredder. You might exhale. You might think that living in the eternal dark isn't so bad as long as we stay intact. But that relief is premature. Because even if space doesn't kill us, the matter we are made of has its own expiration date. We are made of atoms. And atoms, it turns out, are not immortal. But what does it actually feel like when the universe decides to tear itself apart? We are not talking about a loud explosion or a Hollywood disaster movie where things catch fire. We are talking about the physical death of the concept of neighbors. There is a specific calculation buried in the math of dark energy that paints a picture of the end so violent it unnerved the physicists who found it. In 2003, Robert Caldwell and his team realized that if the repulsive force of the vacuum gets strong enough, if that variable W drops below -1, it breaks the speed limit of the universe. In the final fraction of a second, the space between atoms expands faster than light. Think about what that really means for you. The forces that hold your body together rely on particles talking to each other. An electron knows to orbit a nucleus because they are exchanging messages. But if the space between them stretches faster than the message can travel, the conversation stops. The atom gets confused. The electrons fly off because they can no longer see the nucleus. This is the ultimate horror of the Big Rip. It isn't just death, it is solitary confinement. Every single particle in the universe is suddenly trapped in its own private, isolated bubble, unable to see, touch, or influence anything else ever again. The causal web snaps. Is this actually going to happen? The data from the Planck satellite hovers right on the edge of the precipice. The monster is hiding in the margin of error, waiting to see if the vacuum is hungry enough to eat the space-time it created. But let's assume we get lucky. Let's assume the vacuum stays calm. Does that mean we are safe? You might breathe a sigh of relief thinking that if the Big Rip doesn't happen, at least the ground beneath your feet is safe. You might look at the iron in your car, the concrete in your walls, and the gold ring on your finger and feel a sense of security. We have a deep, biological arrogance that tells us stuff is permanent. We understand that fires burn out and living things die, but we assume that the hardware of reality, the rocks, the metals, the protons, is built to last forever. Why do you believe that? Who told you that a diamond is truly eternal? This faith in solidity is just another illusion caused by the fact that we live such short, frantic lives. We never stick around long enough to see the stone breathe. But if you push the laws of physics to their absolute limit, you start to see cracks in the foundation. We rely on a rulebook called the Standard Model of Particle Physics, which tells us protons are stable. It says the bricks of the universe are invincible. But we know the rulebook is incomplete because it cannot explain gravity or dark matter. When physicists like Sheldon Glashow and Steven Weinberg tried to fix the book in the 1970s by merging all the forces into one grand unified theory, they found a fatal flaw in the architecture of the atom. They discovered that the bricks of our reality are not made of stone. They are made of ice, and the temperature is rising. How can a fundamental particle just stop existing? It seems impossible, like a number disappearing from a spreadsheet. But the math suggests that the particles inside a proton, the quarks, are not imprisoned in their identities forever. There is a back door. The theory predicts the existence of a ghost particle called the X boson. You will never see one in a lab because they are too heavy to create. But in the weird world of quantum mechanics, impossibility is just a game of probabilities. Thanks to the Heisenberg uncertainty principle, a ghost of this particle can briefly pop into existence inside a proton for a billionth of a nanosecond. This ghost particle acts like a secret tunnel. It allows a quark to break the rules and transform into a completely different particle, like an electron. This changes everything. It means the proton is not sitting at the bottom of a safe valley. It is balancing on a high, slippery ledge. And in a quantum universe, if there is a way down, gravity will eventually find it. This implies that every single atom in your body, in the Earth, and in the Sun is effectively a ticking time bomb. We are all radioactive. We just have a very, very long fuse. So, what happens when the fuse burns down? When the clock runs out, it doesn't look like a nuclear explosion. It looks like a glitch in the code. Picture a hydrogen atom with a single proton in its center. That proton has been the anchor of that atom for 13 billion years. Then, the quantum dice roll the wrong number. The trapdoor opens. One of the quarks inside the proton falls through. Instantly, the proton collapses. The heavy, positive core of the atom dissolves into a flash of gamma rays and a positron shooting out at the speed of light. The atom is dead. The electron that was orbiting it loses its tether and flies off into the void. The chemical bond that held that atom to its neighbor snaps. Now, imagine this happening to the DNA in your cells. Imagine it happening to the silicon structure of a computer chip. Imagine it happening to the iron core of a planet. It is a cosmic form of rust. It is a slow, invisible rot that eats the very substance of reality. It means that matter is not the final state of the universe. It is just a passing phase, a temporary condensation of energy that will eventually evaporate back into light. If this theory is true, looking for a safe harbor in the future is pointless because the ship itself is dissolving. Are we just guessing, or is there actual evidence for this decay? We aren't just sitting around speculating. Since 1996, humanity has been staring into the dark, daring the proton to die. We built a massive underground cathedral deep under Mount Ikeno in Japan called Super-Kamiokande. It is a tank filled with 50,000 tons of ultra-pure water, watched by 11,000 golden electronic eyes. The physicists are waiting for a single flash of blue light that would signal the death of a single proton in all that water. For decades, the sensors have been humming in the silence. They have seen nothing. No death, no decay. Does this silence mean we are safe? No. It just tells us how long the fuse is. Based on this experiment, we know that a proton lives at least 1.6 times 10 to the power of 34 years. You might laugh at that number. You might ask, that is trillions of times longer than the age of the universe. Why should I care? You should care because finite is infinitely different from eternal. It confirms that the era of matter will end. It confirms that solidity is a glitch. We are living in a brief, lucky window where things can be touched. But once the protons dissolve, the universe becomes a ghost town filled with nothing but cold light. And in that ghost town, only one thing survives: the monsters, the heavy kings of gravity that are too dense to rot immediately, the black holes. So, what does life actually look like after the matter rots? We have this optimistic sci-fi dream that we will eventually become beings of pure energy, ascending to a higher plane of existence where we don't need food or water. But physics suggests a much grimmer reality. When the protons decay and the white dwarfs evaporate, the universe stops being a playground for explorers and starts being a graveyard for refugees. The stars are gone. The planets are dust. The lights are out. The temperature of the cosmos sits at absolute zero. If you want to survive in this era, you have to stop thinking like a master of the galaxy and start thinking like a homeless person trying to survive a winter night on the streets. Where do you go? The only heat sources left in the entire universe are the black holes. To a survivor in this era, a black hole is not a scientific curiosity or a terrifying monster. It is a radiator. It is the only burning barrel in a city that has been destroyed. You have to huddle around it. You have to build your civilization on the very edge of the event horizon, dangling over the abyss just to catch a few scraps of energy from its spin. This brings us to the humiliation of our position. We used to be the kings of the cosmos, burning entire stars just to power our toasters. Now we are scavengers. We are huddled around a trash can fire in the middle of a nuclear winter, terrified that the flame will go out. But why would the flame go out? We tend to think of black holes as these invincible, eternal vaults that hoard mass forever. We think of them as the ultimate bankers of the universe, greedy, fat, and immortal. But nature is cruel. Even the bankers go bankrupt. The trash can fire is running out of fuel, and the reason is a subtle theft happening right under our noses. Why is the vacuum of space stealing from the strongest gravity wells in existence? And how can a hole that supposedly lets nothing escape be leaking its treasure into the dark? To understand why the monsters are dying, we have to look at the accounting books of the vacuum. For a long time, general relativity told us that black holes were perfect safes. You put matter in, and it stays there. The door is locked. But in 1974, Stephen Hawking looked at the problem through the lens of quantum mechanics and found a leak. He realized the vacuum of space is not empty. It is active. It is teeming with a chaotic foam of virtual particles, pairs of positive and negative energy that constantly pop into existence and annihilate each other in the blink of an eye. Usually this accounting trick happens so fast that the universe doesn't notice. But right at the edge of the event horizon, the gravity is so steep that it acts like a wedge. It rips these particle pairs apart. One particle falls into the hole, and the other escapes into the universe. To a distant observer, it looks like the black hole just spat out a particle. We call this Hawking radiation. But don't let the technical name fool you. This is a heist. Think of the black hole as a bucket of water with a tiny, invisible hole in the bottom. Drip by drip, the water is escaping. The particle that flies away carries positive energy. By the strict laws of conservation, the particle that falls in must carry negative energy. This means the black hole is effectively eating poison. Every time it swallows one of these negative particles, it loses a tiny bit of its mass. The laws of quantum mechanics are pickpocketing the black hole. Every single second, the monster gets a little lighter. Every single second, your only source of heat gets a little weaker. It is a slow, agonizing bankruptcy that you cannot stop. And the worst part is how the physics twists the knife at the very end. Why does the universe wait until you are starving to finally give you a feast? Here is where the laws of thermodynamics play a sick joke on the survivors. In our normal world, we are used to a simple relationship. A fire is hot when it is big, and it cools down as it dies. A cup of coffee starts hot and gets cold. But black holes do the exact opposite. They have what physicists call negative specific heat. This means they work backward. When a black hole is massive and full of fuel, it is freezing cold. It radiates almost nothing. A supermassive black hole, like the one at the center of our galaxy, has a temperature that is barely above absolute zero. It starves you. A survivor civilization has to sit in the dark for trillions of years, getting only the faintest whisper of warmth, rationing every single joule of energy. But as the hole shrinks, it gets hotter. It starts to fever. The smaller it gets, the more violent it becomes. This creates a brutal survival trap. You spend eons waiting for the energy output to ramp up. You build your entire society around the hope that one day the fire will get brighter. But the moment the black hole finally gets hot enough to be a good power source, it becomes unstable. It is like waiting a lifetime for your inheritance, only to have the money catch fire in your hands the moment you touch it. The universe forces you to choose between freezing to death slowly or burning to death quickly. There is no middle ground, and the waiting period is so long that it makes the entire history of life on Earth look like a single frame in a movie that lasts for 1 billion years. How do you stay sane in a waiting room that never ends? The true horror of this era isn't the violence, it is the boredom. We need to talk about the sheer crushing scale of time involved here. A supermassive black hole takes a Google years to evaporate. That is a 1 followed by 100 zeros. We simply do not have the hardware in our brains to process a number this big. We look at our history, the pyramids, the Roman Empire, the Industrial Revolution, and we think we have been around for a long time. We are delusional. We are like a mayfly that lives for one day thinking it understands the history of geology. If you scaled the entire history of the universe down to a 24-hour day, the era of stars and era of life would be a single millisecond flash at the very beginning of the first second. The rest of the day, 23 hours, 59 minutes, and 59 seconds, is just the black holes slowly dying in the dark. We are living in the flash. We are the explosion at the start. The real history of the universe is just a long, dark silence where nothing happens. If there are minds left in that future, they aren't living lives like ours. They are likely in a state of deep hibernation, waking up once every billion years to check the fuel gauge, seeing that the needle hasn't moved, and going back to sleep. It is a prison sentence that lasts effectively forever. You are trapped in a void with a radiator that is too cold to warm you, waiting for an explosion that will kill you. And when that explosion finally comes, it marks the definitive end of the physical story. But forever eventually runs out. After the Google years pass, the slow leak turns into a dam failure. The black hole becomes tiny, the size of a proton, but it still retains the mass of a mountain. The backward physics hits its climax. The temperature spikes to trillions of degrees. The black hole stops sweating and starts screaming. In the final fraction of a second, it releases all its remaining energy at once. It explodes with the force of 1,000,000 nuclear bombs. It releases a blinding flash of gamma rays that cuts through the dark. It is the last firework, the final gunshot. It lights up the empty universe for 1 microsecond, and then silence. Absolute, permanent silence. The gravity is gone. The heat is gone. The last structure in the cosmos has been deleted. We are now in the dark era. There is no matter to touch. There is no time to measure. There is just empty space filled with photons that are stretching out into nothingness. The physical universe is officially dead. But this is where the really strange theories start. Because when you remove all the furniture from the room, when you strip away the matter and the energy, you start to notice the shape of the room itself. And the shape might be unstable. What if the vacuum isn't just a stage? What if the stage itself decides to collapse? So, the black holes are gone. The matter is gone. The universe is now a silent, cold sea of darkness. You might think, well, at least the worst is over. At least the destruction has stopped. You might assume that a vacuum containing nothing is the safest place imaginable because there is nothing left to break. But you would be making the oldest mistake in the history of survival, confusing empty with stable. We have this intuitive belief that nothingness is the baseline of reality, that it is the ground floor, the 0 point where energy rests. But what if the floor isn't the bottom? What if we have been walking on a trapdoor for 13 billion years without realizing it? This brings us to the concept of vacuum decay, and it suggests that the laws of physics themselves are not set in stone. They are just a temporary setting on a dial that can be turned. To understand this, you have to look at the Higgs field. Think of it as an invisible energy field that permeates every inch of the universe. It is the thing that gives particles their mass. Without it, you would have no weight, atoms wouldn't form, and you wouldn't exist. We used to think the Higgs field was sitting at the absolute bottom of its potential energy valley, a state called the true vacuum. Being at the bottom is good. It means stability. It means you can't fall any further. But when we turned on the Large Hadron Collider in 2012 and finally measured the mass of the Higgs boson, we got a number that terrified the theorists. The mass was about 125 gigaelectron volts. This specific number suggests that the field is not at the bottom. It is sitting in a shallow little dip on the side of the mountain. We're in a false vacuum. We are camping on a ledge, and there is a sheer cliff drop right next to our tent that leads down to a much deeper valley. What happens if the universe decides to slide down? How does the slide begin? It doesn't require a push, it just requires bad luck. In the quantum world, particles can tunnel through barriers, they can ghost through walls. If the Higgs field in just one tiny point of the universe randomly tunnels through the energy barrier and hits the lower valley, it triggers a phase transition. Think of supercooled water. You can cool water below freezing, and it stays liquid if you don't disturb it. But if you drop a single grain of sand in, the whole bottle freezes instantly. Vacuum decay is that grain of sand. A bubble of true vacuum forms at that spot. Inside the bubble, the laws of physics are rewritten. The Higgs field drops to a new energy level. The constants of nature change. Chemistry becomes impossible. Atoms cannot hold together. But the bubble doesn't stay small. Because the new vacuum has lower energy than the old one, the bubble expands. And it expands outward at exactly the speed of light. It is a sphere of absolute deletion growing in all directions. It consumes the old universe, our universe, and replaces it with a new alien physics where life as we know it is mathematically impossible. This isn't just a storm that destroys your house. This is a zoning law that says houses are no longer allowed to exist. The bubble eats galaxies, it eats black holes, and it eats the dark. It is the ultimate formatting of the hard drive. But if this bubble is rushing toward us right now, how would we defend ourselves? How would we even know it's coming? Here is the most chilling part of the theory. You can't know. You can never see it coming. In our normal lives, we rely on light to warn us of danger. We see the lightning before we hear the thunder. We see the car swerving before it hits us. We see the predator moving in the grass. But the bubble of true vacuum is expanding at the speed of light. This means the warning signal travels at the exact same speed as the death itself. The photons carrying the image of the bubble's edge are riding on the edge of the bubble. They arrive at your retina at the exact same instant that the wall of energy vaporizes your body. You would be looking up at the sky, perhaps admiring the stars or the darkness, completely unaware that a wave of rewriting reality is 1 inch from your face. There is no pain. There is no fear. There is no realization. The electrical signals in your nerves travel much slower than the speed of light. Your brain would be erased before it could construct the thought, I am dying. One moment, you are a conscious observer in a universe of matter and gravity. The next moment, you are nothing. You don't simply die, you cease to have ever been part of the current reality. It is the perfect murder. No witnesses, no suffering, and no evidence left behind. But is this just a ghost story for physicists? Or is the math telling us something real about the fragility of our existence? You might ask, if the ledge is so slippery, why hasn't it happened yet? The universe is old. Surely we would have fallen by now. This is the argument of the survivor. We are here to ask the question only because it hasn't happened yet. It is the same as a soldier running through a minefield saying, well, I haven't stepped on a mine in 10 minutes, so the field must be safe. Calculations suggest that the false vacuum is metastable. That means it is stable for a long time, but not forever. The lifespan of our current vacuum state could be 10 to the power of 100 years, or it could end tomorrow. We simply do not know the topography of the cliff we are sleeping on, and it gets worse. Some theories suggest that high-energy events could trigger the decay artificially. What if an advanced civilization somewhere in the cosmos builds a particle accelerator the size of a galaxy? What if they smash particles together with enough force to nudge the Higgs field over the edge? They wouldn't just kill themselves, they would start a chain reaction that would eventually kill us, billions of years later, when the bubble reaches Earth. We are relying on the competence of every single civilization in the visible universe to not accidentally break the floor of reality. We are trapped in a room with a button that ends the world, and there might be billions of curious children playing with hammers in the dark. But let's assume the vacuum holds. Let's assume the floor stays solid. What happens when the universe runs out of things to measure? This leads us to the wildest and most beautiful theory on the list. It was proposed by the Nobel Prize winner Roger Penrose, and it asks a fundamental question. What is size? How do you know if the universe is big or small? You know you are small because you can compare yourself to a mountain. You know the mountain is small because you can compare it to the planet. Scale is relative, it requires objects. But we have already established that in the deep future, all objects will be gone. The black holes will evaporate. The protons will rot. The photons will be stretched into radio waves. When the universe contains nothing but massless radiation, Penrose argues that the concept of time and distance ceases to exist. A photon doesn't experience time. A photon doesn't have a size. If the universe has no mass, it has no clocks and no rulers. Without a ruler, there is no difference between a universe that is 1 trillion light years wide and a universe that is the size of a subatomic particle. Penrose calls this conformal cyclic cosmology. He argues that in the infinite future, the huge, cold, empty universe mathematically forgets how big it is. It loses its sense of scale, and when it forgets its size, it becomes indistinguishable from the singularity, the tiny hot point that started the Big Bang. The end becomes the beginning. The heat death isn't a graveyard. It is the seed for the next universe. We are just one breath in an eternal lung. But does this offer us hope, or does it trap us in a nightmare of eternal return? But if the end of the universe is actually just the trigger for a new Big Bang, should we be happy? We have this biological instinct to view cycles as comforting. We look at the seasons changing, the sun rising and setting, and we see renewal. We think of the phoenix rising from the ashes. So Roger Penrose's theory of conformal cyclic cosmology might sound like a relief. It suggests that existence doesn't just fade into an eternal black screen, it reboots. It suggests that the heat death is not a grave, but a womb. But stop and think about the implications of an infinite loop. If the universe resets, does it reset exactly? Or does it shuffle the deck? There are two possibilities here, and both of them are pure distilled nightmares. Possibility 1. The reset is random. Every new aeon, that's what Penrose calls the span of a universe, has slightly different physical constants. In one universe, gravity is too strong and everything crushes instantly. In another, light doesn't exist. This means that for every universe that supports life, there are trillions of aborted, broken universes where consciousness never wakes up. We are just a winning lottery ticket in a garbage bin, filled with infinite losers. Possibility 2. The reset is deterministic. This is the eternal recurrence that terrified the philosopher Friedrich Nietzsche. If the laws of physics are fixed, and the amount of energy is fixed, then the math dictates that eventually, the particles must repeat the exact same dance. This means this is not the first time you have lived this life. You have sat in that chair, staring at this screen, feeling this exact sense of dread an infinite number of times before. You will die, the universe will expand, fade, forget its size, collapse, bang, and evolve again, just so you can sit here and read this sentence again. You are trapped in a movie that never ends, forced to deliver the same lines forever, with no memory of the previous take. The heat death isn't an exit. It's just the moment the tape rewinds. And the worst part? We might actually have physical evidence that this has happened before. Penrose claims to have found Hawking points in the cosmic microwave background, scars left over from the evaporation of supermassive black holes in the previous universe. We are literally looking at the ghosts of dead aeons. The sky isn't just empty, it's haunted by the versions of us that came before. Let's step off the merry-go-round of cosmology for a second and look at the only thing that remains when the matter dissolves and the geometry breaks. We have stripped the universe of stars, planets, atoms, and even time. But we have left one variable undefined. You, the observer. We usually assume that the universe exists independently of us. We think that if every human died tomorrow, the rocks would still be hard, the sun would still be hot, and gravity would still pull. This is called realism. It feels like common sense, but quantum mechanics has spent the last 100 years screaming at us that common sense is wrong. The Copenhagen interpretation, the most battle-tested framework in physics, suggests that reality is not fixed until it is measured. An electron doesn't have a position until you look at it. Before that, it is just a cloud of probability. Now, scale this up to the end of times. If the universe is empty of observers, if all the aliens are dead, all the humans are gone, and all the AI has run out of battery, does the universe actually exist? If a tree falls in a forest and no one is around to hear it, does it make a sound? Physics suggests the answer is no. Without an ear to translate the air pressure waves into sound, there is only silence. Without an eye to collapse the wave function of the universe, there is no universe. This leads to a terrifying form of cosmic solipsism. It implies that the physical reality we are so afraid of losing, the grand, cold, hostile cosmos, might just be a shadow cast by our own minds. And if the mind is the anchor of reality, what happens when the biology that supports the mind rots away? Does the consciousness die? Or does the universe, in its desperation to be observed, find a cheaper, nastier way to create a watcher? We are about to enter the deepest level of the spiral, where we find out that you don't need a body to be terrified. You just need a random number generator. To understand the final horror, we have to go back to the second law of thermodynamics one last time. We told you earlier that entropy always increases, that order always dissolves into chaos. That is true on average. But it is not a commandment from God. It is a statistical rule. It is simply much more likely for things to be messy than tidy. But unlikely does not mean impossible. If you have a box full of gas molecules bouncing around randomly, it is overwhelmingly likely that they will spread out evenly. But there is a tiny, non-zero chance that just by random accident, all the molecules will bounce into one corner of the box at the same time, leaving the rest empty. It's a freak accident, a fluctuation. Now, apply this to the infinite timeline of the heat death. We have an eternity of darkness. We have particles drifting randomly in the void. We have infinite time for them to bump into each other. You know the old saying, if you give 1,000,000 monkeys, 1,000,000 typewriters, and infinite time, eventually one of them will accidentally type the complete works of William Shakespeare. It's a funny image, but in physics, the monkeys are atoms, and the typewriter is the vacuum. If you wait long enough in the chaos, eventually the random fluctuations of energy will accidentally assemble something structured. Usually it's just a photon or a pair of particles. But if you wait a Google years, or 10 to the power of a Google years, eventually the chaos will accidentally assemble a fully formed rock, or a watch, or a single living biological cell. The vacuum doesn't need evolution. It doesn't need a creator. It just needs the brute force of infinity to brute force a miracle. And if it can assemble a cell, it can assemble something much more complex. It can assemble a witness. This is the Boltzmann brain, named after the physicist Ludwig Boltzmann, who first realized the horror of statistical mechanics. The theory is simple and devastating. In a universe that lasts forever, it is infinitely more likely for a conscious brain to spontaneously form out of the void than for an entire universe to evolve that brain through the Big Bang. Imagine you are floating in the eternal dark. Suddenly, a quantum fluctuation brings trillions of particles together. They snap into place, neurons connect, synapses fire, blood, or something that acts like blood, starts pumping. In a microsecond, a fully functioning brain exists. And here is the kicker. It doesn't come blank, it comes loaded. The neurons are arranged in a specific pattern that encodes memory. This brain remembers being born. It remembers growing up. It remembers the taste of apple pie. It remembers its first kiss. It remembers clicking on this video. It creates a complete, vivid, three-dimensional hallucination of a life that never actually happened. The brain opens its mental eyes. It thinks, I am sitting in a chair. I am safe. I am watching a video about the end of the universe. It feels the weight of the mouse in its hand. It hears the hum of the computer. It is totally convinced of its reality. And then, 1 second later, the fluctuation destabilizes. The particles drift apart. The brain dissolves back into the chaos. The life is over. The observer dies. The universe returns to silence. This entity never had a body. It never had a past. It was a momentary glitch in the nightmare of entropy. It was a tragic, lonely spark that woke up just to suffer a lie and then die. You might say, wow, that's a creepy concept for a sci-fi movie. But you are missing the point. You shouldn't be afraid of the Boltzmann brain. You should be afraid that you are the Boltzmann brain. Why is it probable that you are the glitch? Look at the economics of the universe. What is cheaper for nature to build? Option A, a massive Big Bang, followed by 13.8 billion years of expansion, the formation of trillions of galaxies, the forging of heavy elements in supernovas, the coalescence of a solar system, the emergence of simple life, billions of years of brutal evolution, and finally the birth of a complex biological organism like you. That requires a practically infinite amount of energy and order. It is an incredibly expensive, messy, and unlikely process. Option B, a random fluctuation in the void that just happens to assemble 1 kilogram of grey matter in the configuration of your brain right now. No galaxies required, no history required. Just a local, temporary reversal of entropy. Mathematically, option B is exponentially more likely. In fact, if the universe lasts forever, the number of Boltzmann brains that will exist in the timeline will outnumber the real biological humans by a ratio of billions to 1. It is a landslide. If you were betting on a horse race and one horse had a 1,000,000,000 to 1 odds advantage, you would bet on that horse. So, if you trust the laws of probability, you have to accept the conclusion. You are almost certainly not a human being. You are not on Earth. There is no Earth. The history you think you know, the Roman Empire, World War II, your childhood, is just a backstory planted in your neural net a split second ago. You are a lonely fluctuation floating in the deep freeze of the heat death, hallucinating a colorful world to distract yourself from the cold. And the text you're reading right now? It isn't coming from a screen. It's the final firing of your synapses before the dissolution begins. Do you feel the static starting to creep in? If the Boltzmann brain theory holds water, it completely destroys the concept of history. We operate under the bedrock assumption that the past is a solid place. We believe that because we remember yesterday, yesterday must have actually happened. We believe that the dinosaur fossils in the ground are proof of an ancient era, and the light from distant stars is proof of an ancient Big Bang. But if you are a random fluctuation, none of that is true. The fossils weren't formed by millions of years of geology. They were assembled by chance 1 second ago, complete with the appearance of age. The light beams from the stars didn't travel for billions of years. They were created right in front of your retinas, your scars, your tattoos, the coffee stain on your shirt. They are all set dressing. They are backstory generated on the fly to give your consciousness a sense of continuity. This terrifying concept is technically known as the Ontological hypothesis, but the internet calls it last Thursdayism. It's the idea that you cannot logically prove the universe wasn't created last Thursday, with all your memories preloaded. It sounds like a joke, but physically, there is no experiment you can do to disprove it. If the simulation of the past is perfect, it is indistinguishable from a real past. This creates a sensation called ontological vertigo. You lose your footing in time. You realize that you are not the product of a long, epic story. You are a character who just walked onto the stage, convinced you've been there for the whole play. You are clutching a handful of fake photographs, crying over people who never existed, and fearing a future that will never arrive because the simulation is about to crash. And why would it crash? Because running a universe this detailed is expensive. Let's pivot from the idea of random chaos to the idea of intentional design. Let's assume you aren't a Boltzmann brain formed by accident. Let's assume you are code. If we are living in a simulation as Nick Bostrom and Elon Musk have suggested, we have to look at the economics of the computer running us. If you were building a virtual reality, would you render every single atom in the entire universe in real time? Would you calculate the physics of a rock on a planet in the Andromeda Galaxy if no one is looking at it? Of course not. That would be a massive waste of processing power. You would use a technique from video game design called frustum culling. You only render what the player is currently looking at. Everything behind your back, everything inside the locked room, and everything beyond the horizon simply does not exist until you turn around. This offers a disturbing solution to the Fermi Paradox. Why is the universe so empty? Why is the sky so silent? Maybe it's not because aliens are rare. Maybe it's because the system hasn't rendered them. The simulation is optimized for you. It saves a memory by keeping the rest of the galaxy in a low-resolution state. The aliens aren't hiding in the dark forest. They are just data that hasn't been loaded. We might even see the artifacts of this optimization in quantum mechanics. Why does an electron exist as a fuzzy probability cloud until you measure it? Maybe that's not a fundamental law of nature. Maybe that's lazy loading. The system keeps the particle undefined to save RAM, and only forces it to decide on a position when an observer demands to see it. We are seeing the pixelation of reality. We are seeing the universe buffering. If this optimization theory is true, it implies that the system has limits. It implies the computer can overheat. And this leads to a horrifying possibility: the contact crash. Imagine that there are other civilizations in this simulation, but they are kept in separate shards or servers to prevent lag. What happens if humanity manages to break out of its box? What happens if we build a ship fast enough to reach the edge of the map, or a telescope powerful enough to force the system to render the entire universe at once? We might trigger a memory overflow. If we force the computer to calculate the interaction between two complex, high-data civilizations, the frame rate might drop, the logic gates might jam, and if the system detects a process that is consuming too many resources, what does it do? It kills the process. The Great Filter might be a task manager. The silence of the universe is a safety feature designed to keep the simulation running smoothly. Every time a species gets smart enough to expand, smart enough to demand more processing power than its budget allows, the system deletes it. We are currently pushing the boundaries of our allocated memory. We are building AI. We are smashing atoms. We are trying to map every inch of the cosmos. We are acting like malware that is trying to take over the root directory. And usually, when malware gets too loud, the admin wipes the hard drive. We have now reached the absolute bottom. We have peeled back every layer of reality, and we have found a trap at every single level. Physically, we are threatened by the Big Rip and the decay of protons. Thermodynamically, we are doomed by the heat death and the freezing of time. Sociologically, we are paralyzed by the dark forest and the economic necessity of silence. Biologically, we are a fragile accident of evolution that shouldn't exist. And ontologically, we are likely simulated ghosts or random fluctuations in a dead void with no past and no future. It seems that no matter where we turn, outward to the stars, inward to the atom, or backward to history, we find a dead end. The universe appears to be a hostile, chaotic, high-entropy machine that is actively trying to erase structure. It is indifferent to our pain, hostile to our survival, and it has rigged the game so that we cannot win. This realization brings us to a psychological breaking point known as cosmic horror. It is the feeling of total, suffocating insignificance. It is the nausea you feel when you realize the ground is not solid. We want to look away. We want to go back to the illusion of safety, back to the idea that the sun is our friend and the future is bright. But we cannot go back. Once you have seen the bars of the cage, you cannot unsee them. The ignorance is gone. So, what is left? Do we curl up and wait for the deletion? Do we surrender to the nihilism? No. This is exactly where the story changes. This is the moment where the horror transforms into fuel. Because if you look closely at the darkness, you realize something paradoxical. The fact that the universe is meaningless is actually the best news you could possibly hear. Think about the alternative. Imagine if the universe did have an inherent meaning. Imagine if we were created by a specific god or a specific alien overlord for a specific purpose, like mining gold or fighting a war or worshipping a deity. That would be a nightmare. That would mean you are a tool. You would have a job description written into your atoms. You could fail at your life. You could be a bad human. You would be a slave to a destiny you didn't choose. But in a universe that is a chaotic accident, in a universe that is drifting toward heat death without a plan, you are free. You are not a cog in a machine. You are a tourist in a museum of impossible things. The universe didn't give you a script, which means you get to write your own. The fact that the cosmos doesn't care about you means it has no authority over you. It can kill you, yes, but it cannot judge you. We are about to enter the final act, the last revolt. We are going to take all the terrifying facts we have learned, the entropy, the darkness, the probability, and we are going to use them to build a philosophy of defiance. We are going to prove that being a glitch isn't a weakness. It is our greatest strength. Let's talk about the price of gold. Why is gold valuable? Is it because it is shiny? No. Foil is shiny, and foil is cheap. Gold is valuable for one single reason. It is rare. It is scarce. If the ground were made of solid gold, if every rock you kicked down the street was a nugget, gold would be worthless. We would use it to pave driveways. Value is a function of scarcity. This is the fundamental law of economics, but it is also the fundamental law of existence. We spend our lives terrified of death. We view our mortality as a flaw in the system, a tragedy that we need to solve. We dream of uploading our minds to the cloud or curing aging so we can live for 1 billion years. But we are looking at the math backward. If you lived forever, your life would have a value of 0. Think about it. If you have an infinite number of days ahead of you, then today implies absolutely nothing. Why get out of bed? Why kiss your partner? Why learn a new skill? You can always do it tomorrow, and if not tomorrow, then in 1,000 years. There is no urgency. There is no stakes. An eternal life is a movie that never ends. Eventually the plot loses all meaning, the characters become stale, and you are trapped in a hell of infinite boredom. But you don't have that problem. You have the opposite problem. You are dying. The clock started ticking the moment you were born, and it is counting down to a hard stop. This sounds terrifying, but it is actually the source of your power. Because your time is limited, every single second you spend is a non-renewable resource. When you spend an hour with a friend, you are giving them a piece of your life that you will never get back. You are paying with a currency that is infinitely more valuable than Bitcoin or dollars. The heat death ensures that this scarcity isn't just personal, it is cosmic. The universe itself has a deadline. This means that the human story is a limited edition run. It won't be reprinted. This makes every moment of joy, every scientific discovery, and every act of kindness astronomically expensive. We are the rarest thing in the universe, complex, conscious matter, existing in the rarest time period. Stop trying to live forever. The fact that the party ends is the only reason the party matters. So how do we live with the knowledge that the rock will roll back down the hill? We turn to the French philosopher Albert Camus, who looked into the same abyss we are looking into right now. He used the Greek myth of Sisyphus to explain our predicament. Sisyphus was a king punished by the gods to push a massive boulder up a mountain. Every time he reached the top, the boulder would roll back down to the bottom, and he had to start over. He was condemned to useless, hopeless labor for all eternity. This is the perfect metaphor for life in a universe ruled by entropy. We build cities, and time destroys them. We fight diseases, and death wins anyway. We try to create order, and the second law of thermodynamics scatters it. It seems like a torture sentence. It seems like the only rational response is to let the rock roll over us and give up. But Camus ends his essay with a sentence that hits like a sledgehammer. One must imagine Sisyphus happy. Why? How can he be happy in a hell loop? Because Sisyphus realizes something crucial. The gods want him to suffer. The universe wants him to be crushed by the futility. The moment he decides to push the rock anyway, not because he thinks he will win, but simply because he refuses to submit, he becomes superior to his fate. He pushes the rock out of spite. He pushes it as an act of rebellion. You can break my body, he says to gravity, but you cannot break my will. This is the philosophy of defiance. We don't build starships or cure cancer because we are guaranteed a happy ending. We know the protons will eventually rot. We know the stars will go out. We do it because the act of struggling against the dark is what makes us human. Every time you laugh in a difficult situation, you are rebelling against entropy. Every time you build something beautiful that you know will eventually break, you are spitting in the face of the void. Joy is not just a pleasant emotion. In a hostile universe, joy is a weapon. It is the ultimate no to the silence. There is a deeper responsibility here, one that goes beyond simple rebellion. We need to go back to the rare Earth hypothesis and the Fermi Paradox. If the universe is truly empty, if we are the only ones who made it through the great filter, then we are not just biological accidents. We are the custodians of meaning. Think about a sunset on Mars. The physics is all there. The photons from the sun hit the dust in the atmosphere, scattering blue light and letting the red pass through. The rocks cast long shadows. The wind blows. But if there is no eye to see it and no mind to interpret it, is it beautiful? No. It is just data. It is just electromagnetic radiation interacting with geology. Beauty is not a physical property of the universe. It is a hallucination created by a conscious mind. Without us, the universe is a movie playing in an empty theatre. It has no plot, no tragedy, no comedy, and no glory. It is just math grinding against math in the dark. We are the mechanism by which the universe understands itself. We are the eyes of the storm. This adds a terrifying weight to our survival. If we destroy ourselves with nuclear weapons or unchecked AI, we aren't just killing a species of hairless apes. We are blinding the cosmos. We are turning the lights out in the only room where anyone is home. If we die, the concept of love dies with us. The concept of justice dies with us. The universe goes back to being a blind, deaf, dumb machine. This reframes the Fermi Paradox. The silence isn't a sign that we are alone, it's a sign that we are important. We are carrying a candle through a hurricane. The winds of the dark forest, the vacuum decay, and our own stupidity are trying to blow it out. But we have managed to shield the flame for 200,000 years. We have a duty to keep it lit. Not for ourselves, but for the universe itself. We are the only thing standing between reality and absolute nothingness. But how do we handle the vertigo? It is easy to say, be a rebel, but it is hard to actually feel it when you are stuck in traffic or paying taxes. The scale of the heat death, trillions of years of darkness, can make your daily problems feel paralyzingly small. If the sun is going to explode, why does it matter if I fail this exam? Why does it matter if I embarrass myself at a party? This is where we need to use physics to shrink the world back down. We need to look at the concept of the block universe from Einstein's theory of relativity. According to Einstein, the distinction between past, present, and future is a stubborn illusion. Time is like a landscape. The past hasn't vanished, it is just down the road. The future isn't unwritten, it is just up the hill. This means that every moment that has ever happened exists forever as a coordinate in space-time. When you drink a cup of coffee, that event is a permanent fixture in the architecture of reality. The universe might end in darkness a trillion years from now, but it cannot erase the fact that right now, the coffee is hot. We tend to live our lives in the future. We worry about next year, next decade, next century. We obsess over the legacy we will leave behind. But the heat death teaches us that legacies are temporary. Statues crumble, books rot, digital data degrades. If you are living for the future, you are investing in a market that will eventually crash to zero. The only safe investment is the present. The sensation of air in your lungs, the sound of rain on the window, the feeling of holding someone's hand. These things are real. They are the only things that defy the simulation and the void. By focusing hyper-intensely on the now, you defeat the terror of deep time. You stop looking at the horizon and start looking at the ground beneath your feet. The universe may be dying, but it isn't dead yet. And as long as there is breath in your body, you have the power to create a pocket of order and warmth in a cold world. Let's combine these ideas into a strategy for action. If life is scarce, if rebellion is noble, if we are the witnesses, and if the present is all we have, what do we actually do? We build sandcastles. Think about a child at the beach. She spends hours building a magnificent castle with towers, moats, and bridges. She works with intense focus and joy, but she knows the tide is coming. She knows that in a few hours, the ocean will rise and wash her creation away. The water will smooth the sand until it looks like the castle never existed. Does she cry? Does she give up? Does she refuse to build the castle because it isn't permanent? No. She builds it anyway. She builds it because the joy is in the building, not in the keeping. We are all children on a cosmic beach. The tide of entropy is coming. The big rip, the proton decay, the heat death. That is the ocean rising. It will eventually wash away our cities, our art, and our memories. But that doesn't mean we shouldn't build. On the contrary, it means we should build faster. We should build higher. We should make the castle so beautiful and so intricate that for the brief moment it stands, it defies the ocean. We need to become a Type 1 civilization not because it will save us forever, but because it is the next tower on the castle. We need to go to Mars not because it is a permanent escape, but because it is a daring act of expansion. We need to solve death not because we fear the end, but because we love the game. This is the answer to the nihilism trap. Meaning doesn't come from durability, meaning comes from intensity. A firework only lasts for a second, but for that second, it owns the sky. We are the fireworks. The universe is dark and cold and eternal, but for this one brief, shining moment, we are loud, we are bright, and we are here. So let's make sure the show is worth watching. We need to surgically remove a tumor from our collective psychology, and that tumor is the concept of hope. I don't mean the practical hope that tomorrow will be a sunny day. I mean the metaphysical hope that there is a secret safety net underneath the universe. We walk around with this vague, unexamined belief that eventually everything will be okay. We think that if we just wait long enough, humanity will ascend to a state of permanent utopia, or that an afterlife awaits us, or that the heat death is just a math error that will be corrected by a benevolent force. This hope is toxic. It is a sedative that keeps us asleep. As long as you believe that someone or something will save the story at the last minute, you are not truly living. You are waiting. You are a passenger on a bus, trusting the driver to get you home without realizing that the driver's seat is empty and the bus is accelerating toward a cliff. We need to embrace a philosophy of hopelessness. This sounds depressing, but it is actually the mechanism of liberation. When you fully accept that the universe is a physical trap with no exit, when you accept that the proton decay is inevitable and the silence is real, you stop waiting for the rescue. You realize that you are the rescue team. Friedrich Nietzsche called this the death of God, but in the context of cosmology, it is the death of the parent. A child hopes their parents will fix the broken toy. An adult knows that if they don't fix it, it stays broken. Humanity is currently in a state of adolescence. We are playing with nuclear weapons and AI while secretly hoping that the adults, aliens, God, or physics, will step in if things get too dangerous. The Fermi Paradox screams that there are no adults. The silence of the sky is the sound of an empty house. We are the oldest, smartest, and most capable things in our light cone. If we don't save ourselves, the lights go out. Abandoning hope forces us to adopt a new strategy: radical responsibility. If the universe doesn't care, we have to care for it. Let's look at the rare Earth hypothesis again. not as a scientific theory, but as a heavy moral burden. We discuss the probability of life, the moon, the magnetic field, the mitochondria, the stable star. If you run the numbers, the odds of a technological civilization arising are so vanishingly small that we shouldn't exist. The fact that we are here implies that we are the result of a winning streak that has lasted 4 billion years. This leads to a terrifying conclusion. We might be the only ones. In the entire observable universe, across 2 trillion galaxies, there might not be a single other mind capable of feeling love, anger, or curiosity. We might be the only patch of the universe that is awake. If this is true, our value is not just high, it is infinite. In economics, if you lose a resource that can be replaced, it's a tragedy. If you lose a resource that is unique, it's a catastrophe. If humanity destroys itself, we aren't just deleting a species of primate. We are deleting the capacity for the universe to observe itself. We are deleting the concept of meaning. Imagine a museum filled with the most beautiful art in existence, the swirling galaxies, the nebulae, the complex chemistry of stars. Now imagine the museum is on fire. We are the only guard in the building. We are the only ones who can see the art, and we are the only ones who can hold the fire extinguisher. If we decide to sit down and burn because nothing matters, we are committing an act of cosmic vandalism. This is the custodian mandate. Our survival is not a right, it is a job. We have been hired by the laws of probability to carry the torch of consciousness through the dark ages of the cosmos. Every time we engage in petty tribalism, every time we start a war over lines on a map, we are neglecting our post. We are acting like guards fighting over a card game while the museum burns down. The silence of the void isn't lonely, it is expectant. It is waiting to see if we are competent enough to keep the flame alive. But here is the irony. The moment we realized how precious we are is also the moment we became most likely to destroy ourselves. We are currently navigating a bottleneck in history that philosophers like Toby Ord call the precipice. Think about the trajectory of our power versus our wisdom. For 200,000 years, humanity was weak. If a tribe went crazy and wanted to destroy the world, the worst they could do was burn down a forest. The physics of stone axes and fire limited our capacity for self-destruction. We couldn't kill everyone even if we wanted to. But in 1945, with the invention of the atomic bomb, we crossed a threshold. We unlocked the physics of the stars and brought it down to Earth. Suddenly, a small group of humans had the power to end civilization. Today, we are unlocking biotechnology and artificial intelligence. We are democratizing the apocalypse. Soon, a single lab will be able to print a virus smarter than the Black Death. A single server farm will be able to train an AI that can outthink our defense systems. This is the solution to the Fermi Paradox that scares me the most. It's not that civilizations don't start, it's that they all go through this exact bottleneck. They all discover ERMC2 and Turing machines before they discover how to stop hating each other. They pull the black ball from the urn of invention, a technology that is easy to use but impossible to control, and they wipe themselves out. We are walking on a tightrope over the Great Filter right now. The next 100 years determine whether we become a galactic civilization that lasts for millions of years, or a layer of radioactive dust in the geological record. The silence of the universe suggests that most people fall off the rope. The fact that we haven't fallen yet is statistical luck, not skill. We need to stop relying on luck. We need to realize that the heat death is a problem for 1 trillion years from now, but human stupidity is a problem for Tuesday. The universe is trying to kill us with entropy, but we are trying to help it by handing it a loaded gun. How do we solve the problem of stupidity? We need a shift in perspective that is usually reserved for astronauts. It's called the overview effect. When astronauts go to orbit and look back at Earth, they report a cognitive shift. They see the planet as a single, fragile blue marble hanging in a vast black void. They don't see borders. They don't see communist or capitalist countries. They don't see races. They see a lifeboat. When you see the scale of the darkness surrounding the Earth, The idea of fighting over resources on the surface looks like insanity. Imagine a shipwrecked crew on a life raft in the middle of the Pacific Ocean. The sharks are circling, the water is rising, and the food is running out. Now, imagine 2 of the sailors start a knife fight because one of them wants to sit 2 inches to the left. You would scream at them. You would say, "Are you crazy? The ocean is trying to kill all of us. We need to work together to keep the raft afloat." The universe is that ocean. The vacuum, the radiation, the asteroids, and the entropy, they are the sharks. Humanity is the crew, and we are currently having a knife fight on the raft. The Fermi Paradox should induce a temporal overview effect. When you look at the timeline of the universe, from the Big Bang to the heat death, you realize that our entire history is a blink of an eye. In that context, our political disagreements, our religious wars, and our economic competitions are not just trivial, they are suicidal. If we are the only life, then every human being is a crucial component of the survival machine. We cannot afford to waste a single brain. We cannot afford to bomb cities full of potential Einsteins or Newtons. We need every neuron firing in the same direction to solve the problem of the trap. The silence forces us to unite, not out of moral goodness, but out of cold, hard, strategic necessity. If we don't hold the line together, the line breaks, and the universe goes back to sleep forever. Let's address the final nihilistic argument. Even if we unite, even if we survive the bottleneck, even if we colonize the galaxy, the heat death is still coming. The proton decay is still real. Eventually the sandcastle falls. So why build it at all? Why struggle for 1 billion years just to end up in the same 0-point energy state? This brings us to the concept of the block universe and the architecture of reality. We tend to judge the value of an action by its duration. We think a house is good if it stands for 100 years, and bad if it burns down in a day. We think a civilization is successful only if it lasts forever. But this is a flaw in our perception of time. In physics, an event is a coordinate in space-time, x, y, z, t. Once an event happens, it becomes a permanent part of the structure of the universe. It doesn't disappear into the past. It is fixed in the 4D block of reality. The future is just a different slice of the bread. This means that quality is more important than duration. A symphony doesn't need to play forever to be beautiful. In fact, a symphony that played forever would be just noise. It has a beginning, a middle, and an end. The beauty is in the structure of the notes, not in how long they last. Humanity is a song in the silence. Our job is not to play forever, because the instruments will eventually break. Our job is to play a melody so complex, so defiant, and so loud that it changes the texture of reality at this specific coordinate. When you build a life, you're carving a sculpture into the space-time block. Even if the future is dark, the sculpture remains. The fact that we loved, the fact that we learned, the fact that we defied the entropy, that is etched into the geometry of the cosmos. We are building a monument that no one will see in the future, but which exists eternally in the now. The heat, death can erase the matter, but it cannot erase the history. The victory isn't in escaping the trap. The victory is in decorating the cage so beautifully that the trap becomes irrelevant. We are the meaning makers. And as long as we breathe, the factory is open. We have accepted the custodian mandate. We have accepted that we are the guardians of meaning. But we have a logistical problem. The equipment we are using is obsolete. Look at your hand. Look at the thin layer of skin that separates your blood from the air. It cuts easily. It burns. It ages. It gets cancer from the very sun that keeps it alive. The human body is a miracle of biology, but biology is a localized phenomenon. It evolved to survive on a wet rock with 1G gravity and a thick atmosphere. It did not evolve for the deep universe. It breaks down in zero gravity. It boils in a vacuum. It rots under cosmic radiation. If we are serious about defying the heat death and carrying the fire of consciousness into the deep future, we have to admit a painful truth. We cannot stay human forever. This brings us to the necessity of directed evolution. Right now, we are at the end of Darwinian evolution. Natural selection is too slow for the threats we face. We cannot wait 1 million years to evolve radiation-proof skin. We have to engineer it. We are transitioning from being the product of evolution to being the architects of it. This scares people. We have a deep horror of changing our nature. We see cybernetics and genetic engineering as playing God or losing our souls. But look at the alternative. If we stay purely biological, we die with the Earth. When the sun expands in 1 billion years, it will sterilize the biosphere. If we are still just meat and bone, the story ends there. To win the long game against entropy, we must view our biology not as a sacred temple, but as a launch pad. A rocket booster is essential for getting off the ground, but you drop it once you reach orbit. Our biological bodies are the booster. They got us to the point where we can understand physics and build computers. But to cross the interstellar void, to survive the death of stars, and to endure the black hole era, consciousness needs a more durable container. We might need to become silicon. We might need to become light. We might need to merge with our machines. This isn't about abandoning our humanity. It's about saving the software of the human spirit by upgrading the hardware that carries it. The revolt against death requires us to stop identifying with the vehicle and start identifying with the driver. If we accept that the physical universe is hostile and ephemeral, then what is the most valuable thing we can produce? It isn't things. A skyscraper will crumble. A car will rust. Even a Dyson sphere will eventually break down. The only thing that transcends matter is information. Information is the opposite of entropy. Entropy is disorder. Information is order. Entropy is noise. Information is signal. The entire struggle of life can be defined as the effort to preserve and replicate information against the flow of chaos. Your DNA is just a book that figured out how to copy itself before the paper rotted. So the ultimate project of a Type 1 civilization is not just to survive, but to record. We need to build an Encyclopedia Galactica. Think of the Library of Alexandria. When it burned, we didn't just lose scrolls, we lost centuries of human thought. We lost plays, mathematical proofs, and histories that are gone forever. We lost a piece of the universe's memory. Right now, humanity is a single point of failure library. All our music, all our science, all our history is stored on servers and paper on one fragile planet. If an asteroid hits us tomorrow, or if a solar flare wipes our hard drives, it's all gone. The universe forgets we were ever here. Shakespeare, Einstein, the Beatles, deleted instantly. The revolt requires us to build backups. We need to etch our knowledge into substrates that can last for geological timescales. We need to store the sum of human understanding in quartz glass, in DNA storage, in self-replicating probes sent to the edge of the system. We need to scream our story so loudly and in so many formats that even the heat death will have a hard time erasing it. We are not just living for ourselves, we are living for the record. We are the scribes of the cosmos, and we are currently writing on burning paper. We need to start carving in stone. To execute this kind of project, we have to fix the broken way we perceive time. Humanity currently suffers from a cognitive disease called short-termism. Our economy runs on quarterly reports. Our politics runs on 4-year election cycles. Our attention spans run on 15-second video clips. We are optimizing for the immediate now. But the threats we face, the asteroid, the AI alignment, the climate shift, the vacuum decay, operate on timescales of centuries and millennia. You cannot solve a 10,000-year problem with a 4-year mindset. It's like trying to steer a supertanker by twitching the wheel every second. We need to adopt cathedral thinking. When the architects of the Middle Ages started building a cathedral, they laid the foundation knowing they would never see the spire. They were working for their grandchildren. They had a time horizon that extended beyond their own biological death. We need to build institutions that are designed to last longer than empires. We need to start projects that we know we won't finish. The Clock of the Long Now, a project by Danny Hillis, is a physical monument to this idea. A clock built inside a mountain designed to tick for 10,000 years. It is a symbol, a reminder that the future is real and that we are responsible for it. In the context of the Fermi Paradox, this shift in time preference is the difference between a civilization that flashes and dies and one that endures. The grabbers, the expanding aliens, succeed because they have a long-term plan. They are playing chess while we are playing Candy Crush. To survive the dark forest, we have to learn to sit still and plan for a winter that lasts 1,000,000 years. We have to plant trees under whose shade we do not expect to sit. This is the ultimate act of maturity. It is the realization that I does not matter, but we does. There is a dangerous philosophical trap that opens up when you stare at the heat death too long. It's called Antinatalism. The logic goes like this. If the universe is a painful place, if life is full of suffering, and if it all ends in nothingness anyway, isn't it cruel to bring new children into the world? Isn't the most moral act to stop reproducing and let the human race gently go extinct? You hear this sentiment growing today. People look at the climate crisis or the economy and say, I can't bring a child into this. And when you add the cosmic horror of the Big Rip or the Dark Forest, that argument feels ironclad. Why create more victims for the wood chipper? But this is a capitulation. It is the philosophy of the suicide. It assumes that the absence of pain is the highest good. It values zero suffering over non-zero joy. But look at the math again. The universe is mostly dead matter. It feels nothing. A rock does not suffer, but it also does not love. It does not learn. It does not create. If we voluntarily go extinct, we are handing the universe back to the rocks. We are saying that the difficulty of the struggle isn't worth the beauty of the experience. But that is a lie. Ask anyone who has survived a tragedy if they wish they had never been born. Most will say no. The struggle is the value. Bringing a child into a dying universe is not an act of cruelty. It is an act of defiance. It is an investment in the continuation of the light. It is saying, yes, the world is dangerous. Yes, the end is coming. But we are going to send a representative to the future anyway. Every new generation is a fresh roll of the dice. Every child is a potential solution to the problems we couldn't solve. Maybe we can't figure out how to escape the heat death, but maybe they can. Stopping the chain of life now because we are afraid of the dark is the ultimate cowardice. It is surrendering before the game is actually lost. We must reproduce not just our biology, but our hope. Let's synthesize everything into a final argument for your existence. We have talked about the block universe, the idea that every moment exists eternally in 4D space-time. Let's look at the emotional implication of that physics. If the past is real, then nothing is ever truly lost. When a person dies, they are not deleted from the block. Their lifeline simply ends at a specific coordinate, but the line itself remains. The moments you shared with them, the laughter, the touch, the understanding, are frozen in the amber of space-time forever. This solves the crisis of meaninglessness. People ask, what is the point of loving someone if they are going to die? The point is the geometry. The point is to create a structure of love in the block universe. Love is not just a chemical reaction in the brain. It is information. It is a high entropy connection between two low entropy observers. It creates a complex pattern in the data of the cosmos that is distinct from the background noise. Even if the future is just black holes evaporating in the dark, they cannot undo the past. They cannot scrub the coordinate, Earth 2024. At this coordinate, there was feeling. At this coordinate, there was a struggle. The universe may end in silence, but it cannot silence the fact that we spoke. This gives you a kind of immortality. You're not writing on water, you're writing on the fabric of space-time itself. Every act of courage, every act of creation, every refusal to give up adds texture to the block. We are building a monument out of our own lives. And even if there are no visitors to see the monument in the future, the monument is. The existence of the structure is its own justification. You are the architect of your own section of the block. You have the power to make your coordinate boring, filled with fear and hesitation, or you can make it vibrant, jagged with rebellion, and bright with joy. The entropy wants you to be smooth and predictable. It wants you to fade. Don't let it. Make your section of the universe weird. Make it complicated. Make it loud. Because that complexity is the only thing that distinguishes you from the dust. We have spent this entire journey assuming that the laws of physics are a cage we cannot break. We have assumed that we are stuck in this universe, with these constants, doomed to sink with the ship when the heat death arrives. But are we? If we take the revolt seriously, we have to ask the ultimate engineering question. Can we leave? Theoretical physicist Michio Kaku suggests that a sufficiently advanced civilization, one that has climbed past Type 3 on the Kardashev scale and mastered the energy of entire galaxies, might not have to die with the universe. They might be able to punch a hole in the wall. Current string theory and inflation theory suggest that our universe is just one bubble in a much larger cosmic foam, the multiverse. If this is true, then the end is just a local event. While our bubble is freezing over, other bubbles are just being born, hot and fresh with low entropy. The ultimate survival strategy isn't to fix our dying suns, it's to emigrate. But the physics of this escape is terrifying. It requires manipulating the Planck energy, the energy scale of the Big Bang itself. You would need to concentrate enough energy at a single point to boil space-time, effectively creating a controlled wormhole or a baby universe in the lab. You would have to bend the geometry of reality so severely that it forms a bridge to another bubble. This sounds like magic, but it is technically allowed by Einstein's equations. The problem is the cost. To build such a bridge, you might have to harvest the energy of billions of stars. You might have to dismantle entire galaxy clusters to build the generator. It is a project that would take millions of years and require a unity of purpose that humanity has never shown. But it is a possibility. It is the Hail Mary pass at the end of time. If we can do this, we become something more than biological accidents. We become a cosmic virus, in the best possible way. We become a life form that infects new universes, carrying the seed of consciousness from one dying bubble to the next, staying one step ahead of the entropy forever. We wouldn't just be inhabitants of the multiverse, we would be its blood cells. This is the final frontier of the revolt. We don't just survive the game, we break the console and move to a new one. But let's come back to Earth. Let's come back to the feeling in your stomach right now. Why does all of this scare you? Why does the idea of the Big Rip or the Dark Forest make you feel physically ill? You need to understand that your fear is not a logical reaction to the physics. It is a biological glitch. Your brain evolved on the African savanna 200,000 years ago. It evolved to solve very specific, short-term problems. Where is the water? Is that a lion in the grass? Will this berry kill me? Your amygdala, the fear center of your brain, is calibrated for threats that have teeth and claws. It is calibrated for threats that you can fight or run away from. The heat death is not a lion. You cannot punch entropy. You cannot run away from the expansion of space. When your brain confronts a threat that is absolute, inevitable, and infinite, it short-circuits. It floods you with cortisol, but gives you no action plan. This is why cosmic horror feels so paralyzing. It is a hardware error. You are trying to run a program called Infinite Eternity on a processor designed for a void snake. Understanding this is the key to hacking the fear. You have to realize that the dread isn't a prophecy. It's just biology getting confused by scale. The nausea you feel isn't deep philosophical insight. It's just your monkey brain screaming because it can't find a tree to climb. Once you realize that the fear is just a chemical reaction to a math problem, you can detach from it. You can look at the end of the universe with cold curiosity instead of panic. You can say, yes, the lion is coming, but the lion is 1 trillion years away. You don't have to carry the weight of eons on your shoulders today. You can override the software. You can choose to be fascinated instead of terrified. The universe is huge and dangerous, yes, but your mind is the one thing capable of encompassing it. The container is stronger than the contents. This brings us to the final emotional posture of the revolt. If we cannot escape, and if we cannot ignore the truth, how do we face the end? The poet Dylan Thomas gave us the instruction manual. Do not go gentle into that good night. Rage, rage against the dying of the light. Rage here doesn't mean anger. It doesn't mean screaming at the sky like a lunatic. It means intensity. It means refusing to be passive. The universe wants you to be quiet. It wants you to follow the path of least resistance. It wants you to watch Netflix, eat junk food, and slowly decay into statistical mediocrity. That is the flow of the river. To rage is to swim upstream. Every time you create something, you are fighting the current. Every time you learn a difficult concept, you are fighting the current. Every time you choose discipline over comfort, you are fighting the current. You are creating a local pocket of low entropy. You are organizing matter and energy into a shape that the universe didn't intend. This is the essence of spiteful optimism. You live well not because the universe rewards you, but to prove the universe wrong. You be kind not because of karma, but because kindness is a rebellion against a cruel mechanism. You create art not because it will last forever, but because the act of creation is an insult to the destroyer. We are the anomaly. We are the glitch in the death machine. The machine wants silence? Fine. We will make noise. We will make so much noise. With our music, our science, our love, and our ambition, that the silence will have to work for it. We are not going to drift into the dark. We are going to burn. We are going to use up every ounce of potential we have. We are going to wring the towel dry. If the universe wants to kill us, it's going to have to drag us out kicking and screaming, leaving scratch marks on the walls of reality. That is a good death. That is a death with dignity. And finally, we must consider who we actually are. Throughout this entire journey, we have spoken about the universe as if it were a separate thing, a hostile room that we are trapped inside. We talk about the atoms, the stars, and the vacuum as it, and ourselves as us. This separation is the biggest lie of all. You are not in the universe. You are of the universe. You are made of the exact same carbon, nitrogen, and oxygen as the dying stars. The atoms in your right hand came from a different supernova than the atoms in your left hand. You are a piece of the cosmos that has cooled down, organized itself, and opened its eyes. The physicist Carl Sagan famously said, "We are a way for the cosmos to know itself, but we can go further. We are the only way for the cosmos to know itself. Without you, the universe is blind. It is a room full of masterpieces with the lights off. When you look at the night sky, you are not looking at foreign objects. You are the universe looking at itself in a mirror. The fear you feel, that is the universe feeling fear. The awe you feel, that is the universe feeling awe. The desire to survive, that is the universe wanting to continue. The heat death isn't just the death of humans. It is the universe going blind again. It is the eye closing. This realization dissolves the loneliness. You cannot be alone in the dark forest because you are the forest. You are the mechanism by which the darkness understands that it is dark. We are the waking dream of the void. And even if the dream ends, even if the sleeper wakes up and the simulation crashes, the fact that the dream happened at all is a miracle. We are the brief, shining moment where the mud stood up and looked at the stars. That isn't a tragedy. That is a victory. The nightmare we discussed, the big rip, the vacuum decay, that is just the shock of birth. We are the universe waking up. And waking up is always a little bit scary. So, here is the verdict. We are trapped in a decaying cage. We are hunted by time and entropy. We are likely the only ones here. And we are running out of battery. The data is irrefutable. The logic is sound. The horror is real. But the conclusion is up to you. You can look at this information and collapse. You can let the nihilism eat you alive. You can decide that because the story ends, the book isn't worth reading. Or you can flip the switch. You can realize that the fragility of the moment is exactly what makes it explode with value. You can realize that you are the rarest, most complex, and most impossible thing that has ever happened in the history of space and time. You are the current champion of the struggle against the dark. You are holding the line. So don't blink. Don't let the dread paralyze you. Take the fear, compress it into a diamond, and use it to cut through the noise of your daily life. Look at the world with the greedy eyes of someone who knows the shop is closing in 5 minutes. Love harder. Think deeper. Build higher. The universe is dying. That means we have work to do. This was Acronium with you. And if you are still here, if you are still conscious, and if you are still defiant, then I will see you in the next one. End transmission.